Hi folks, Brian Benz here, Cloud Advocate at Microsoft, welcoming you to another JDConf 2024 on-demand session. In this session, Timo Salm, who's a senior lead Tanzu DevX solution engineer at Broadcom, is going to cover going serverless with Spring support for GraalVM, Project CraC, and more. In this case, the and more is class data sharing. He covers GraalVM, he covers coordinated restore at checkpoint, which is CraC, and also class data sharing. And the whole idea behind the session is to help you improve the performance and scaling of your serverless applications using the packages I just described. Pretty cool demos, please check it out.
Hi, welcome to the session about going serverless with Spring support for GraalVM, Project CraC, and more. My name is Timo Salm and I'm a pre-sales specialist for developer experience for the VMware Tanzu portfolio at Broadcom. And if we have a look at the agenda, I will first introduce the topic with some slides about what serverless is, and then I will show hands-on different technologies to actually improve the runtime efficiency of your Spring applications to be able to run them on a serverless runtime. Like, for example, GraalVM native images, JVM checkpoint restore with Project CraC, and also class data sharing, and then I will wrap everything up with a short summary. So what is serverless? Actually, serverless doesn't mean that there are no servers, it just means that you don't have to care about them. And it can be grouped into two areas. So the first one is backend as a service, where you replace server-side self-managed components with off-the-shelf services. A good example is, for example, instead of managing your own authorization server, that you use a SaaS service like Auth0. The second group is about function as a service, a new way of building and deploying server-side software oriented around deploying individual functions. And for sure, for example, also get all those benefits of serverless runtime. These functions, they should be stateless, or in general, all the applications you run on such a modern infrastructure. The key about both areas or groups is really that you don't have to manage your own servers or hosts and server process, and therefore can really focus on business value. The outcomes of serverless is that you actually have a shorter lead time, because of the fact that you don't have to care too much about the packaging, and the deployment is a lot easier. So it actually provides a high abstraction for you, and you don't have to care about all the stuff that's happening underneath. The next thing is really about the increased flexibility of scaling. So usually on modern infrastructure, like for example also container runtimes, etc., and the scaling is horizontal instead of vertical, which means that instead of attaching more resources to your virtual machine, you scale horizontally, so just creating more instances. And for that, it's a huge requirement that those applications that you run in those different instances, that they are stateless, so they only share a state via, for example, databases, etc. The next thing, which is also a little bit about that flexibility of scaling, and especially scale to zero, so not having any instance running if there's no demand for it, is about reduced costs for the resources, and also labor costs, which means that you don't need all the people that are managing your full stack if you have, for example, a SaaS service serverless runtime, like for example Azure Container Apps. The next thing is also about the fact that other people are actually managing all your infrastructure stack, so you have reduced risk for that, and also you have in a way reduced risk with that horizontal scaling, which means that you don't have too much downtime, because if one of the instances crashes, there in best case are additional ones, or especially with optimizations we will see later, it's easy, or automatically there will be a new instance available that takes on the traffic. But usually, if you have a solution that provides some outcomes, there are also some drawbacks and limitations. And with serverless, there are a lot of limitations, but it also provides a lot of outcomes. And for sure, one of the limitations is, or other unpredictable costs. For sure, it's possible, especially at SaaS services, but also technologies like native as a serverless runtime that can run on any Kubernetes, that you can define some boundaries. So how many instances you want to spin up is maximum and also minimum. But in general, that's one of the drawbacks. It's also like one of the drawbacks that we will, or you will probably identify, and we will see in a minute with the Java applications, is the startup time. So if you have, for example, scale to zero and your application takes several seconds to spin up, it could be that request timeout, which is not great for the user experience, and for sure has to be handled also on, for example, the front end side. Also, the fact, which I already mentioned, that serverless applications in most of the cases are stateless. So it's the state will be not stored on the disk, and instead maybe in databases, which also means that there's a need for a lot more baking services that legacy applications actually had. The next thing is maybe a vendor login. So if you're using a solution like Azure Container Apps, there's not too much of a login, because you have a container and you can also deploy this container to a different solution. But if you're, for example, packaging your application or writing in a different or special way for a solution like AWS Lambda, it's a different story. But there are also then solutions available, like for example Knative, that are completely open source and run on any Kubernetes. And that's something we will use today. So Knative as a serverless runtime on top of Kubernetes. Another drawback is that, for example, the loss of control over all the stuff you're not responsible for managing anymore. So if there are any problems, you really have to rely on the provider of that service. And there several more, like for example the higher latency due to the communication, especially if you have an application that's built with functions, also microservices, because there's a lot of communication happening instead of having everything in one application where you don't have any latency between the calls. And for this session, I'm using a really basic application to which will already show all the benefits that you can achieve with those different technologies focused on runtime efficiency. And for that, let's first just run this application without any optimizations on a serverless runtime, so Knative. And for that, I will go to my terminal here. Because of the time, they are already deployed. So let's do kubectl get kservice. So that's the name of the Knative custom resource. You can see that's our hello world, and we can use service. What we can see is mostly that's a container image which I've already built, and you can easily use in Spring since version 2.3 the built-in cloud native build pack support, so that you don't have to create a Docker file, and the build packs, they will recognize, oh, it's a Spring application, and build a container image with best practices for you out of the box. In this example here, we're using Gradle, and the Gradle command, for example, is Gradle boot build image, providing the image name, and then the plugin will do everything for you, and you can then push this container to a container registry. That's what we already did. We reference it here, and you can also see some additional capabilities in this service specification which are added after I applied it, like for example traffic splitting, etc. And if we have a look at the pods, so where those application is running on, you can see they're 0, because by default it's configured for scale to 0, which means that you're not, especially on cloud services, but also on the infrastructure energy-wise, you're not you don't have any cost for the stuff because you're actually not using anything. But if we now run a curl for our application, then actually we now have a response. And if we have a look at book pods, you can see, oh, it's there. If we have a look at the logs of our application, we can see that it took 4 seconds to start this application. I said it's really basic. It's just one REST controller that's providing that hello world message. And we have a startup time of 4 seconds. You can imagine if you have a huge application that it's around 15 or 20 or even longer, which means that, those requests, they will time out, which is a problem. For sure, you can pre-provision stuff. So it's also something I can do with Knative or with other Azure Container apps. But then you still have costs even if there are no demand. So because of that, actually, what we should do is, we should see how we can optimize our applications. And that's actually something then we should really do to actually save more costs with the serverless runtime. So first, faster startup time and also the memory consumption. So if we run kubectl top pods for our application, I hope it's still there, we can see that we are actually consuming 200 megabyte of memory here, which is also, if you have a really small application, a function, a lot, especially if you have a lot of functions, and you scale them to hundreds or thousands of instances. So that's something we want to improve. And actually, for that, there are several technologies available nowadays. One of the first ones is GraalVM native images. And if we have a look at GraalVM or native images in general, what it is, actually it's like standalone executables of ahead of time compiled Java code, which means that instead of running the application on a JVM, with a just-in-time compilation, which we see here on the diagram, it's like usually you have a compiler that creates transforms your Java classes into bytecode, and then you have the Java file, and on runtime, the bytecode will be run with an interpreter. And to optimize the performance of frequently used paths in your application, there is a just-in-time compiler which compiles specific parts of the application into native code, so meshing code, which then speeds up those frequently used paths, for example, endpoints or API endpoints. With ahead of time compilation and native images, it's different. So actually the full code will be first compiled to a bytecode, but then on the build phase created as a native image. So machine language based on actually the architecture you build it on, which is also a limitation. And with that, you got a really huge improvement in, for example, startup time, etc. Because all the just-in-time compilation, etc., it reduces a lot of resources and also adds additional startup time. With that, we can really improve the startup time of your applications. And everything this application needs from a JVM perspective is still available, packaged together. It's something with something called Substrate VM, so that everything the application needs, so all the classes, etc., are in this one executable. And it's also like that, for example, things, the class path is which you could change if you run on JVM, is fixed, etc. So it's really like package everything that you need for the runtime into one executable and not being able to add stuff dynamically. And GraalVM, as that, is an advanced JDK from Oracle that is really supports this ahead of time native image compilation. So let's now have a look and run our application. It's also possible, just for information, to build a native image with those build packs that are coming out of the box with Spring Boot. Only thing you have to do, so for GraalVM it's the same command, you just have to add this Gradle plugin here. And with that, the command, the build image command will create a native image. As said, keep in mind that if you do that, the native image will be created based on the architecture you have. So here I have, for example, one M1 Mac, so an ARM processor, and therefore this native image will not run on my Kubernetes cluster, which is based on a different architecture. For Maven, for sure, the same is also available, but there you, after adding the Maven plugin, you have to specify a profile, so profile native for the build pack, and also for the Maven plugin to do it without, which is for sure also possible without directly building a container. That's a little bit different here from the experience. And yeah, what we will do now, as I said, I already deployed everything, so we also have a knative service here. So we can see it here, it's hello world native, and if we run our curl command to provision to start, and if we run our curl command to start our first container, we're able to see how much we were able to improve our application by actually just compiling it to a native image. We can see that the startup time, instead of around 4 seconds, is only 169 milliseconds without changing anything here in the application. So an amazing improvement. And if we have a look at the memory consumption, we should be also able to see some improvement. So we can see it's only 40 maybe byte instead of around 200, and also from a CPU side, it's yeah, half or a third from the resources used from CPU. So really a technology that helps us to make our application serverless ready, and yeah, we can really see the benefits of it, especially if we have scale to 0, as you saw, based on how fast we got a response. But as always, there are unfortunate trade-offs, and one of them is the developer productivity. So because of the time I didn't show you how long it takes to build a container image or a general native image, actually it takes a lot of time compared to your usually yeah, build time. So really, instead of, let's say, 30 seconds, it takes 10 minutes. So that's a huge problem that yeah, is not really solved yet. So there is something available if you want to, for development, so not for production, but for development, that you can speed it up, because there will be not too much optimizations, and therefore also, yeah, the startup time is not that amazing, and also the size, but it's like, it helps you to validate whether the application works like it should be. For developers, that's available, but for production, it takes a lot of time, and therefore the recommendation is, for example, run this newer mode from developer perspective, or also just, yeah, do ahead of time compilation without building a native image to validate the application works on your machine, and yeah, then delegate the building of the production-ready native image to a CI/CD pipeline, which, based on your architecture, is also something more or less required. A huge issue with the GraalVM native images is because of the fact that everything that you execute from a class perspective has to be in the native image. It's not possible out of the box to use dynamic features without giving the GraalVM compiler hints which you would like to use. So they also have support for example, running specific parts of your application, and based on that, creating configuration files that you then give the compiler, that it includes those files. But actually, yeah, it's a lot of effort usually involved, mostly for custom code, because there's all the libraries for sure that are commonly used try to provide the support out of the box. And there's also a huge community around it for those that didn't do that yet, to provide those from a community perspective. And it's about, yeah, dynamic Java features like, for example, reflection, proxies, but also resources. The next thing is that, yeah, from a Spring perspective, to actually get the benefits of the static analysis, some assumptions have to be made, and in a way, yeah, restrictions. And that's really about the fact that the class path is fixed, and also bean conditions are fixed, and also, for example, profiles are not supported. So I said it's really about, okay, you have to actually decide which you want to run on the build time, and then you can actually run that on production. For sure, if you're using profile to switch things between different environments, which depends on whether it's a good idea, other than just configuration, because usually you want to test in a test environment what you would later run in production. That's not possible without building different native images for different environments. And yeah, so for those custom hints, those are usually files that you pack together with your application code. But Spring provides additional support here with a so-called runtime hints registrar interface, where you then support, you can see examples here for reflection, resources, etc., for those dynamic features you are using, and actually how you use them, and then Spring will generate those files for you, but you can also do that manually. For most of the classes that need binding, like for example JSON serialization, that's automatically done for you. But actually, if you're using directly web client or a REST template, you can also use the register reflection for binding annotation. And for sure, if you don't include something and, for example, have good test coverage and run your test, you can immediately see that yeah, it's not working, and then you can, based on that, provide the hints that you need. Okay, so yeah, let's have a look at the next technology that we have. So it's a newer one. It's called JVM Checkpoint Restore with a project CraC. And yeah, what's Project CraC? So CraC means Coordinated Restore at Checkpoint. It's an OpenJDK project initiated by Azure, as far as I know. And actually what it does, it provides a Java API to create a snapshot of a Java process when the application is fully warmed up, and also those optimizations I talked about. If you frequently request or run a specific path in your application with a just-in-time compilation, etc., there's additional optimization happening. And yeah, you can then create a checkpoint and restore it later on. So with a new instance, etc. And with that, you get huge startup improvements with all the optimizations that you do on a training run. And the big benefit of that is that instead of with a GraalVM approach, here you can still use all the dynamic features, etc. It's just like stopping your application and restarting it. Unfortunately, you have it can be that you have to do some optimizations regarding a Java program, but the CraC library provides support for that, and also from a Spring side with the lifecycle start and stop capabilities that you can implement. You can provide the necessary code, and the thing is that yeah, to create a checkpoint, all for example open sockets, etc. have to be closed and then to be restarted after the checkpoint. And that's something, if it's not done out of the box with those typical life cycles in Spring, you have to provide. So it's also time for CraC demo. So let's have a look how the results are. So let's first curl it. It should also not take too long. And if we now run kubectl get kubectl logs, we see a startup time of 169 milliseconds, so really close to the GraalVM native image. If we have a look how to get it running, you can see here that I added one dependency, so that's the CraC library, which is required. For sure, this one then is not required. And additionally, there are several ways on how to actually create, or where to create a checkpoint and do the restore. So in this sample here, I'm doing the checkpoint on the build phase. So in my CI/CD pipeline, for example, via Docker. So I'm first building my application, as you can see here, and then I'm adding all the files I need, and then I have this entry point script that's actually doing the magic. So you can see, based on whether it detects there's a folder with all the checkpoint files or not, it will do a checkpoint, or it will run the application from the checkpoint. And that's all stuff you can get from the documentation, but actually you can see that here what I'm doing is I do this CraC checkpoint 2 with a directory and my jar file, and then I wait for 30 seconds, and then I run because my application just provides an API endpoint at this default path here, or root path, and run some curls, actually request against the application for the optimization regarding that path. And then there is, that's what CraC provides, there's a command to actually run this JDK checkpoint command, which will shut down, as said, all the, or close all the connections, shut down everything, do the checkpoint, and then restart the application. And then yeah, just waiting for some time after it's created. And then from a startup or runtime perspective, there is the CraC restore from with a folder that will then actually restore this checkpoint. And yeah, with that, we really get those benefits. One thing I have to note here is that one problem also is that you actually need some privileges there. So you can see that I have to set some Linux capabilities to restore my application. So checkpoint restore sys ptrace and run as root. So yeah, that's an advancement compared to before, where you have to run it as a privilege, which is great. And it's also like you have to check that the Linux distribution you're running your application or also creating checkpoint actually supports and those Linux capabilities, which is not the case until now for all. Also, you may have recognized that I'm using a special JDK here with a CraC postfix, so it's also something you have to ensure that you're, for example, from Azure use a JDK that actually has CraC included, because it's not available in any in every open JDK or JDK yet. For the summary of the trade-offs, the first one is really that yeah, the checkpoint, you have to start the application, for example, also in your CI/CD pipeline. And yeah, you have to ensure that all the circuits are closed, etc., and restart. That's also something, if it's not out of the box available for all the functionality, you have to do yourself. One huge problem is regarding the checkpoint that first, for sure, you have to ensure, in best case, that your application is optimized for those typical paths, which is not, maybe after some time you know which APIs, for example, call the most, and then you can adjust it in your CI/CD pipeline. But there's another problem, which is that it's yeah, because of the fact that we're actually starting a JVM with everything set up and stopping it, for sure all the connections to the databases, etc., should be all, and also the production database should be in this checkpoint. Otherwise, it's we will not get the benefits, and therefore it's necessary, for example, to do a checkpoint against your production database for the image build for production. But the problem is that then in this checkpoint, you have all the information about the secrets. And this is also why we already tested a solution where we actually do the checkpoint on the runtime, so that you have one container image for all the environments, but you do a checkpoint, so with similar entry files that you saw in your Kubernetes cluster, for example. And then this checkpoint will be saved, or snapshot will be saved to a persistent volume or something else like an S3 bucket or whatever storage option. And then the other instances, so if you do autoscaling, they those snapshot is mounted to those additional instances, they will pick it up and start from it. So really doing the checkpoint and the restore on the runtime, that's the solution for that, but it's a little bit more complex to set up. But that, from my perspective, is the recommended way if you care about credentials, etc. And as already said, it's Linux specific, and you also it requires some Linux capabilities that are not available to every Linux distribution yet. So, and there's one more option, which is class data sharing. So what is it about? So actually, it's like there for a long time, more or less, and it's a JVM feature. It also reduces the memory footprint and the startup time, so like GraalVM. The thing is that it's it continuously also involved, especially with enhancements in the upcoming project Layden, where it will be really also provide additional an enhanced version of class data sharing together with ahead of time compilation, and we have initial support for it in Spring Framework 6.1. It's actually not restrictive less restrictive compared to GraalVM and Project CraC, so it more or less just works. The only thing you have to keep in mind is like the improvements are not that high then with the other two technologies, and therefore it's maybe not the best solution for example, scale to zero, but it's a nice way with a minimal effort to improve the startup time and memory consumption of your application if you, for example, have a lot of time similar demand and using it more for HA, etc. Let's also have a look here. And we can see here that it took around 2.6 seconds. So compared to 4 seconds, a huge improvement as that with a minimal effort, even if it's currently still like some effort involved. But that's also something we can maybe from a Spring Boot perspective optimize for you if there's interest in using it. And what I had to do to get it working is like that's hugely depending on as everything, because he's the lead of all that runtime optimization stuff, Sebastian. You can also see the source here, so if you'd like to have a closer look. And actually, what it does is the requirement is that the jar files is unpacked in a specific format, and then there will be a training run with that Spring context exit on refresh. That's also something available for Project CraC to automatically do a snapshot. And what it does, it's starting the application, but not the life cycle, and exiting it automatically. And then we have those JVM properties, archive classes at exit to here, and as it's automatically exited, we'll just start, exit, and then provide all the information for the class data sharing functionality. And then on the runtime, we have the shared archive file to reference those. And that's all put together in the Docker file, so building the application, and then actually running the CDS script for the build, and actually using it. And if we have a look at this shell script also from Sebastian, we can see also how the structure looks like. But even it looks like a little bit complex for now. It's just about preparing the structure in a little bit different way, and the rest works without any modifications, which is really great. The trade-offs of class data sharing are mostly that the improvements are not that dramatic. One restriction currently is that executable jars. This is why we unpacked it, and unpacked deployments, which is a recommendation to run applications in production for also improved startup time. You can read that in the Spring documentation. It's not supported yet. But that's something hopefully will be changed soon from a Spring Boot perspective. One limitation is that the JDK and the class paths should be the same on the creation of the archive and the restore. Actually, the summary of all we did is that if you have faster startup times and lower memory overhead, you can really reduce the cost of your applications, especially if you have applications with a lot of users. It's not only about reducing costs, it's also about stability and high availability, because if one of the instances or several are not available with those huge or fast startups times, it can self-heal fast enough to not let your users run into timeouts. GraalVM native image is one of the technologies which provides the most improvements for startup time and memory consumption, but yeah, it has really constraints, especially about those hints you need for dynamic features and also the build times. Next technology, JVM checkpoint restore with Project CraC, so it's not that major and provides similar improvements regarding startup time, but not for memory consumption. And yeah, it also has several constraints, and one of them is really that where you create a checkpoint, which I said about the leak of credentials, probably better on the runtime than the build time. And last but not least, we have task data sharing as one of the solutions. I think especially in the future with Project Lane, that will be really commonly used, but because of the improvements are not that dramatic than with the other solutions, not for scale to zero use cases, more like, okay, improving the stuff a little bit. And if you have, I would say, regular demand and not too much peaks in too much peaks or scale to zero. And yeah, that's it from my side. Thank you very much.
Thanks for watching. Check out this and more at jdconf.com.